Your web application is hosted on EC2 instances behind an application load balancer, ALB. During flash sales, the application experiences sudden and unpredictable traffic spikes. You need a cost-effective solution to handle traffic bursts while keeping latency low. Options: A. Increase the instance size of the EC2 instances. B. Use auto-scaling to launch additional EC2 instances based on CPU utilization. C. Migrate the application to Lambda with API Gateway. D. Use Elastic Beanstalk with spot instances to manage the scaling automatically. Correct answer: B. Use auto-scaling to launch additional EC2 instances based on CPU utilization. Explanation: auto-scaling ensures that additional EC2 instances are launched automatically during traffic spikes, maintaining performance while being cost-effective. Scaling based on CPU utilization is a standard metric to handle bursts effectively. Why not other options? Option A. Increasing instance size is not dynamic and leads to unnecessary costs during low traffic. Option C. Migrating to Lambda would require re-architecting the application, which is not feasible under immediate load conditions. Option D. Elastic Beanstalk automates management but might not offer the fine-grained control that auto-scaling provides. You manage a financial institution that needs to retain transaction logs for 7 years for compliance purposes. The logs must be easily retrievable for the first 30 days and move to a cost-effective solution afterward. Options: A. Store the logs in S3 Standard with lifecycle rules to transition to S3 Glacier Deep Archive after 30 days. B. Store the logs in S3 Standard IA and delete them after 7 years. C. Store the logs in S3 One Zone IA to reduce costs. D. Use RDS for transaction logs and enable automated backups. Correct answer: A. Store the logs in S3 Standard with lifecycle rules to transition to S3 Glacier Deep Archive after 30 days. Explanation: S3 Standard ensures durability and availability for the first 30 days when access is frequent. S3 Glacier Deep Archive provides a cost-effective solution for long-term retention with infrequent access. Why not other options? Option B. S3 Standard IA is costlier for frequent access in the first 30 days. Option C. S3 One Zone IA sacrifices durability, which is unacceptable for compliance data. Option D. RDS is designed for relational database workloads, not for cost-effective log storage. You are designing a real-time analytics system that processes clickstream data from millions of users. The system must provide low-latency writes and support SQL queries for reporting. Options: A. Use RDS MySQL with a multi-AZ configuration. B. Use DynamoDB with Global Secondary Indexes, GSI. C. Use Amazon Redshift for real-time ingestion and querying. D. Use Amazon Aurora with a reader endpoint for analytics. Correct answer: D. Use Amazon Aurora with a reader endpoint for analytics. Explanation: Aurora provides high-performance, low-latency writes and supports SQL queries, making it ideal for real-time analytics. Reader endpoints allow horizontal scaling for read-intensive workloads. Why not other options? Option A. RDS MySQL may not scale effectively for high throughput. Option B. DynamoDB is great for low-latency writes, but does not natively support SQL queries. Option C. Redshift is optimized for OLAP, batch analytics, not real-time ingestion. You are hosting a website with static content, HTML, CSS, JS, images. The website must deliver content quickly to users globally, and access to certain files should be restricted to authenticated users. Options: A. Use S3 with public bucket policies for all files. B. Use S3 with CloudFront and signed URLs for restricted files. C. Use EC2 instances with an ALB and IAM roles for access control. D. Use S3 with lifecycle rules to delete restricted files after a specific period. Correct answer: B. Use S3 with CloudFront and signed URLs for restricted files. Explanation: S3 stores the content, and CloudFront accelerates delivery with edge locations. Signed URLs enforce restricted access for specific files. Why not other options? Option A, public bucket policies expose sensitive files. Option C, using EC2 and ALB is overengineering for static content hosting. Option D, lifecycle rules manage file deletion, not access control. Your application runs in multiple AWS regions. You need to ensure that users in different regions experience low-latency access to a central database while maintaining data consistency. Options: A. Use RDS with multi-AZ configuration. B. Use Aurora Global Database. C. Use DynamoDB with global tables. D. Use S3 with cross-region replication. Correct answer: B. Use Aurora Global Database. Explanation: Aurora Global Database replicates data across regions with sub-second latency, ensuring low-latency access and strong consistency. Why not other options? Option A, multi-AZ is only for high availability within a single region. Option C, DynamoDB global tables are great for NoSQL, but unsuitable for relational database workloads. Option D, S3 is not a database and cannot support transactional workloads. You need to migrate a large amount of on-premises data, 100 terabytes, to AWS. The migration must be completed within a week, and the data must be encrypted during transfer. Options: A. Use AWS Direct Connect with encryption enabled. B. Use AWS Snowball Edge to transfer the data physically. C. Use S3 transfer acceleration for faster uploads. D. Use AWS Storage Gateway to synchronize the data. Correct answer: B. Use AWS Snowball Edge to transfer the data physically. Explanation: Snowball Edge is designed for bulk data transfer, encrypts data by default, and supports terabyte-scale migrations efficiently. Why not other options? Option A, Direct Connect is not suitable for transferring 100 terabytes in a week. Option C, S3 transfer acceleration is too slow for such a large dataset. Option D, Storage Gateway is better for incremental synchronization, not bulk transfers. You are building a social media platform where users can upload photos, comment on posts, and like content. The platform must handle millions of requests per second and support low-latency data retrieval. Additionally, the database needs to be able to scale horizontally. Options: A. Use Amazon RDS with read replicas for scalability. B. Use Amazon DynamoDB with DynamoDB Accelerator, DAX. C. Use Amazon Aurora with global database enabled. D. Use Amazon Redshift for storing and querying data. Correct answer: B. Use Amazon DynamoDB with DynamoDB Accelerator, DAX. Explanation: DynamoDB is a NoSQL database designed for high throughput and low latency access, perfect for scenarios like social media platforms. DAX provides in-memory caching, reducing latency further for read-heavy workloads. Why not other options? Option A, RDS is a relational database that does not scale horizontally as efficiently as DynamoDB for NoSQL workloads. Option C, Aurora is best suited for relational data, not NoSQL. Option D, Redshift is optimized for analytics, not real-time operational queries. You are developing a RESTful API for a retail application. The API must be secure, scalable, and cost-effective. You also want to ensure that only authenticated users can access the API. Options: A. Deploy the API on EC2 instances and use IAM roles for access control. B. Use API Gateway with Lambda authorizers for authentication. C. Use ALB with EC2 instances and enforce security using security groups. D. Use AWS Elastic Beanstalk and set up custom authentication logic. Correct answer: B. Use API Gateway with Lambda authorizers for authentication. Explanation: API Gateway allows you to create and manage APIs securely. Lambda authorizers provide a serverless way to authenticate users, ensuring scalability and cost-effectiveness. Why not other options? Option A, EC2 requires more effort to scale and manage securely. Option C, ALB is not designed to manage APIs or authentication logic directly. Option D, elastic beanstalk requires custom development, increasing complexity unnecessarily. Your company is building a data lake to store raw data from IoT devices and process it for analytics. Data must be stored cost-effectively, and analytics queries should have low latency. Options: A. Store data in S3 Glacier and use Redshift Spectrum for querying. B. Store data in S3 Standard and use Amazon Athena for querying. C. Use S3 Intelligent Tiering and process data with Amazon EMR. D. Store data in EBS volumes and use Amazon Redshift for analytics. Correct answer: B. Store data in S3 Standard and use Amazon Athena for querying. Explanation: S3 Standard provides high durability and availability for frequently accessed data. Amazon Athena allows you to run SQL queries directly on data stored in S3, making it cost-effective and scalable. Why not other options? Option A, S3 Glacier is for archival and not optimized for frequent querying. Option C, S3 Intelligent Tiering adds cost for tiering, and EMR is overkill for simple queries. Option D, EBS is not designed for large-scale, cost-effective data storage. You are deploying a 3-tier web application on AWS. The architecture includes a front-end, an application layer, and a database layer. You need to ensure maximum security while maintaining performance. Options: A. Use security groups to control traffic between layers and expose the database to the internet for administrative access. B. Use security groups for layer communication and a NAT gateway for internet access. C. Use security groups for communication between layers and AWS Systems Manager Session Manager for database access. D. Use a single security group for all layers and manage access using IAM roles. Correct answer: C. Use security groups for communication between layers and AWS Systems Manager Session Manager for database access. Explanation: security groups provide granular control over traffic between application layers. Systems Manager Session Manager enables secure, auditable database access without exposing it to the internet. Why not other options? Option A, exposing the database to the internet is a security risk. Option B, a NAT gateway adds internet access, but does not solve the security issue for database access. Option D, using a single security group is not granular enough for secure multi-tier applications.